Hello, in this video, I'm going to talk about the formulas of integration with integrand of this form, where there's a rational function with fx a function and the numerator is the differential of this function. Okay, so let's see what's the formula, right? So I call this as a third formula, as there's a video, in the previous video I introduced you about integrate 1 over x and integrate 1 over ax plus b, and for this I'm going to introduce the third formula, which integrate f prime x fx dx. So if you have, this is your differential and this is your function, and the formula directly you can just write as ln fx plus c. Alright, so this is very easy. As long as you see this form of integrand, then this is your after integration, this is your function. Alright, so let's look at examples 1. Right, examples 1. So I have 4x is a rational function, right? So then I can observe that when I differentiating this, if I differentiating this, so I will getting 4x, right? I will getting 4x. Differentiate 3, you're getting 0. So it means that my fx in this case is 2x squared plus 3. So, and if you differentiate f prime x, then you have 2 to 4x. So you will see that this is your f prime x and this is your fx, right? You can see very clearly here. So now you can apply this formula. What is formula? It's ln of the function of the denominator, right? So in this case, so you have to put ln modulus of 2x squared plus 3 plus with c. Alright, this is fine if you're not putting modulus in this case, because 2x squared plus 3 is always positive, right? So I can write as 2x squared plus 3 plus c, right? So this is the answer for this problem. So we go for more examples to show you how to using this formula. Right, okay, let's move on to these examples. And okay, we try to observe that you cannot apply ln directly, but for this case there is a function on top and down here, right? So and you can check whether this one can be differentiated and getting this function or not. Okay, we can have a check. So you know that my fx to be 4x squared plus 2x plus 1. So we try to differentiate to see the situation here. So differentiate, we have 2, 4, 8x plus with 2, right? So suppose here you must have 8x plus 2. Means that you want to apply this formula, you must have f prime x on top. Okay, but this is 8x plus 2 and this is 4x plus 1. But we can modify this so that we can apply this formula. Alright, try to pay attention here. So we can try to multiply, right? If you want to get 8x plus 2, if you want to get 8x plus 2, I just need to multiply. Okay, I write it back 4x plus 1 over with 4x power of 2 plus 2x plus 1 dx. Everything is about balancing. So here you have 8x plus 2. 8x plus 2 is 4x plus 1 multiply with 2, right? Multiply with 2. So in order for using that formula, I have to put a 2. I have to multiply this one with 2, right? So that I getting 8x plus 2. So if I putting 2 here, I have to balance back by 1 over 2, right? Because 1 over 2 multiply 2, you'll get back the original one, right? So now we need the help of this 2 in order for this to become f prime x, right? Now this whole thing is become your f prime x, and this is your fx. Alright, so easily I can apply that formula. So which is 1 over 2 ln of the fx, modulus of 4x squared plus 2x plus 1 plus c. Alright, okay, I hope you understand, and let's move on for the next example. Right, okay, let's look at this. So I can see that this one can using this formula. Why? How you know that this you can apply that formula, right? First, you have a lot of practice. Secondly, you know differentiation very well. You see that if you differentiate something x power 4, you are getting something x power 3, right? So I believe that you will need this formula here. So I just write it out. 1 minus x power, this will become my fx, right? My fx. So, and I try to differentiate. Differentiate 1, 0. Differentiate negative x power 4, you have negative 4x power 3. Where I see there is a x cubed here, right? Even though they have no negative 4 there. But we can try to put negative 4 here by balancing, right? Negative 1 over 4 here, so that we can using this formula. So how would I do? I will doing this way, right? 1 minus x power 4 dx, and this one I will adding a negative 4 x cubed. So I will divide by 1 over negative 4, so that you will get back what is in the original integrand, right? So now you have f prime x. Now you have f prime x. You have f prime x on top here, and you will have fx here. So we can start applying that formula, right? So negative 1 over 4, right? So in the bracket, we have ln modulus 1 minus x power 4 plus with c. Very easy. Ln fx. If you can see f prime x over fx, then ln fx. So that's the way I apply that formula. We go for more examples so that you have a very clear understanding about this. Alright, okay, let's look at these examples. Okay, it's actually that you find out it will be very difficult for you to see which formula to use, alright, because there are so many formula. So that's why you need practice, right? You need practice. So for now, you see that, so let's say you have fx. Sometimes you can have a quick check in your mind when you differentiate, will you get something there or not? That is very important. You must have a quick check in your mind. So now you have fx to be 2 plus ex. So if you differentiate, what will it be? So you differentiate, of course, you're getting differentiate 2, you're getting 0. Differentiate ex, you're getting ex, right? Then you can see that there is an ex there, right? There is an ex there. So I just need to factorize the 2 out. I just need to take out the 2, and I will fulfill the condition to using this formula, right? So if you see that fx, this will be f prime x, right? Your f prime x. So now you can using that formula. So which will be 2 ln modulus 2 plus ex plus c. And this is always positive, right? Exponent plus 2 is always positive. Okay, this is always positive. So you can just ignore the modulus. So then you have plus c as your solution here. Okay. Let's go for another examples. Okay, you can try first for this. So as I can see that, differentiate exponent to the power of negative x. In the quick check, I can know that you can get exponent power of negative x. So that's why I will consider this formula, right? This formula. So it will be 3e to the power of negative x minus 1. And if you differentiate, you will have negative 3e to the power of negative x, right? Copy back, differentiate the power negative, right? Differentiate this one, you're getting 0. You just need a negative 3 here, right? You just need a negative 3 in front of here, so that you become f prime x, right? So I just add a negative 3. I cannot just add it negative 3. I have to divide it by negative 3 as well, so that balance, right? So I add a negative 1 or 3. So if I cancel, I get back the original one. So now you can see that this is your fx. Okay, this is your fx, and this is your f prime x. So I can apply that formula, and got negative 1 over 3 ln modulus of 3e negative x minus 1 plus c. Alright, so that's the way we apply that formula. So let's see more examples. Right, how about this? Right? So it's a trigonometric function, okay? But you can see that if you differentiate cos, you are getting sine, right? So means I think this formula can apply. So what I do is I just letting the fx to be 3 cos x minus 1. Alright, so if I differentiate, I will getting differentiate 3 cos x. Cos, you differentiate cos, you are getting negative sine x. So negative 3 sine x. And here negative 1, you differentiate, getting 0. So, so as long as you have a negative 3 there, you can apply that formula, right? So, okay, I just write back sine x divided by 3 cos x minus 1 dx. So you need a negative 3 here, right? Based on here, f prime negative 3. But you cannot just simply put negative 3. You have to balance back by divide a negative 3 here. So then you can directly using the formula negative 1 over 3. Right? This is your fx. Now this is your fx. Right? And this is your f prime x. Your f prime x. So you can directly put ln, based on that formula, ln modulus of the fx. 3 cos x minus 1 plus c. Alright, hope you're getting better in knowing how to using that formula. Alright, okay, let's look at this. This will be the last examples. So I'm going to show you this as a final one so that you understand that formula. So first, there's a trigo, so we don't know whether, okay, what's the method? So you have to consider this one if you have this division here, a rational function. So you have to consider this formula. Maybe this is one of the formula that helping you to integrate. So let's say I have my fx to be x minus with sine square x, right? So before I differentiate, usually I will asking student to write this as a sine x to the power of 2, right? Sine x to the power of 2. So then I start differentiating. So if I start differentiating, I will getting differentiating x, you have 1, right? So negative, bring down the power, so apply the chain rule. So sine x, right, 2, sine x, and the 2 you minus 1, it become 1. And don't forget to differentiate the sine, which will giving you cos x, right? So if you are very familiar with trigonometric formula, double angle, identities, then you can see that this is actually double angle formula, 2 sine x cos x. You can refer to the formula sheet, then you can getting sine 2x, right? Which is exactly above there, right? Which is, this is exactly your f prime x, right? And this is your fx. So then if you know how to perform differentiation and you know some identity for trigonometric function that you always remember, so then it will be very easy to solve this problem here. So you just put a ln, because this is f prime x is fx, so you just put ln modulus x minus sine to the power of 2x plus c. As easy as that. Alright, I hope you understand and you have to try more questions to getting better. Alright, so that's all for this video.